This meeting is being recorded.
Hello everyone, this is Ahmed Mahgoub, and today I'm going to explain here about Lab1 in computer organization and architecture. So first of all, we're going to start with this code. This code basically performs just basic operations for the registers and other variables. This code starts with the title and subtract version, etc. So this is just like the title for the code. And here the including for this library element 32 is this library is responsible for assembly language. And after that, we are going here is the data. Our data is val1, val2, and val3. Val1 is 10,000 hexadecimal the word. Val2 is 40,000 the word in hexadecimal also, and val3 also the word 20,000 hexadecimal. Val3 is also unsigned long, but until now we don't have a value for final val, and this value is going to come after we perform some operations, basic operations in assembly language. And here is the main code process, and here is the operations that we are going to perform. The first operation is that we are going to move val1, which is this value. We are going to move it to the register EAX, and then we are going to add this value, which is val2, to the register our register, and then we are going to subtract this value val3 from the register. And after that, finally, we are going to do this operation. We are going to move the register value into the final val, and here final val is going to have a value, and we are going to store it the result. And this is called dump register. This is for displaying the registers in the output. And here is the finishing of the main and the finishing of the program. So let's first of all start the debugging with start the building without debugging. So rebuild the resolution, and here we are going to start without debugging. As you can see, here is the output. Here is our register EEX. It have the value of 30,000 if we perform these operations, adding moving val1 to EEX, which is 10,000 if I'm not mistaken, and then adding this value to that value, and then deleting this value, which is 20,000 from 50,000. We are going to get 30,000, which is the value of the EEX, and then it's the same value of the final value because we assigned it later. So this is the process of building without debugging. Let's start debugging right now. We press F10. After we press F10, we go to debug. We want to show 5 windows. The first window we want to show is the registers window. Here is the register window. We have our register EAX, the register EPX, ECX, EDX, ESX, EDX, and EIX, and ESX. And we are going to have another windows, which is disassembly window. Here we can trace our program, the values of each, the operations and the values. And we have also the memory, which is, I guess here, yes, the memory window. Here we can see the memory clearly. And we also have window for the watch. I guess it's down here, and the autos. I added the watch variables already to the watch, val1, val2, val3, and final val. I add them to the watch already.
This meeting is being recorded.
And here we are going to trace the program. And here we are going to trace the results of this code after debugging. So yeah, we should have 5 windows. We have a window for watch, and we have a window for the autos, a window for memory, and a window for registers, and disassembly. Disassembly is basically just to try to trace the code, and registers to spot the changes in the registers values, and the memory also to spot the changes in the memory and addresses, and the watch also to spot the changes in the values we have in this program. All those also for the registers. So let's first of all start with the watch. Let's press F10 to spot the changes in our watch. So first of all, we have the final val is 0. We have the other values, each one with its value. You can see it in 8 bits because it's word, D word variables, and we can see the EX or register, which is unsigned integer. Let's press F10 and go to the other operation. We can see now EX have a value which is 10,000 after we press F10, after we move the val1 to the EX. Now EX have a value. And after that, we add the val2 to the EEX, and now EEX have 50,000 as its value. And now we move, we subtract the val2 from EEX, and now EEX have a value of 10,000. We can spot the changes like this, line by line, by pressing F10. And now after we move EEX to the final val, now we can see final val have a value which is 30,000, same value as EEX. And here, just to display the output, that's it for the watch. Now let's spot the changes in the autos, which is basically a little bit same to the watch. Let's press F10. Let's go to the disassembly. Let's press F10. We can see now EX have a value after we press F10, and the value is 10,000. Now it becomes 50,000 after we perform the operation of the addition, and now it's 30,000 after the operation of the subtraction. It's only one register, which is EX. That's why we can see only EX. And that's it for the autos. Let's now go to the register. Right now, you can see register in the top. If we perform a press, you can see the value of the registers change: EEX, EIP, addition, operation after operation. EEX have been changing, the addition operation, subtraction division, same like. So basically, if we just keep pressing F10, we are going to spot the changes in the register operation after operation. And now let's go to the final one, which is the memory. Let's go to the disassembly and let's press F1. Yes. Let's copy the address and put in the memory one like this, and press F10. F10, we can see the changes of each address in the memory bar, the top, same like this. If we keep pressing F10, we can see it clearly, I guess. Now we show the memory, the registers, the autos, and the watch, and that's all for part B. Now let's move to part C. And here is part C, the final code. This code, same like the previous one, it has the title, including data. The data here is val1, val b1, which is a byte value, 10 hexadecimal, val b2, a byte value, 40 hexadecimal, val b3, byte value also, 20 hexadecimal, and the final value b, byte also, but it does not have a value yet. Same, we'll do the same process here. We move a val1 to AX register. Here we add the val2 to AX register. Here we subtract val3 from AX register, and here we move AX to the final val W register. Which is here, here is val1 W, so which is a word, 1000 hexadecimal, val W2. Word also 4000 hexadecimal, val W3, word 2000, and here is operations, move a val W1 here, and here is final W, which is a word variable, doesn't have a value. Here we will have a value after we move AX to store AX value in this value, and here we just display the registers. Here is val WB1, we will move it to AH register, and we'll perform the same thing. Let's go to, first of all, to do the building without debugging, rebuild the solution. Okay, successful. Let's see. Started. Here is the building after. We can see it's 16 bit. We can see the output. Let's now go to step over. After we press F10, we go here, we can see the memory, the watch, everything. Let's go to watch. Let's add our variables, clear this all. Let's add val b1, val b2, val b3, val w1, val w2, val w3, final, val b, final, val w. And let's add also the registers, which is AX, AH. I guess this is all. Let's see the main. Yes, we are going to deal with AX and AH. So let's spot the changes in the in our watch first of all. So let's go to the disassembly, press F10, and here is the first operation, move val w1 to AX. After that, here we move the val w1 to AX, so the value of AX change, and here we subtract the val w2 from AX, so we can see also the AX value change, and we can spot that final val w and final val b have 0, which is unsigned short and unsigned character. We can go like this. You can see the changes occurs operation after operation until the end of the code. The AX value and the final B value, it will gain a value after we move the value of AH to the final val B. We can see final val B have the same value of AH right now, and after that we can see until the end of the code. We just spot the changes in all the variables. We have all the values like this in our code. So now let's go to the memory, spot the changes in the memory. Or let's go to the register first. Here is the register. Here is the disassembly. Let's go F10. This is the final value. We can spot the changes in EIP, and then EIX. You can spot the changes in all. In every line in the code, you can see the changes in the registers values EAX and EIP, which is the most two register that changes. We are dealing with these registers in our code. We spot the registers, we spot the changes in the register, let's spot the changes in the memory. After that, let's go to the memory, F10. You can go disassembly. Here, let's go to this address. Yep. After that, again, let's go to this address. After we move the value of AX to the val W, you can see all the changes line by line in the memory. And here is just the calling. So basically, yep, and F10, F10, F10. In each memory address, you can spot the changes, different changes from the previous one. And here we are going to deal with the autos. We are going to show the changes in the autos. Go to disassembly. Here is the autos, and we are going to step over. So here we have the value of AX. which is FP88, and here we have after we add the value of val W2 to AX, we can spot the change in the value the register AX have been changing. After that become 5,000, 3,000. Operation after operation it will change depend on the operation. And here the second register, which is AH, appears, which is have a value of 30. And step over again, we can see the changes in the two registers after we add val WP to AH. The val AH have been changed, and after that we subtract. After that we move the value val WP to AH, and after that, so AX register have been removed, and this is just for displaying the AH register, and that's all about the orders. And that's all. I guess that's all for each. In the first example, we talk about operations, simple operations for the single register, and in the second part C, we talk about simple operations, also add subtraction and move for the set two registers in one code. And I guess that's all. Thank you.